This question says water flows through the system with no air inside, according to the arrows. At which point is the velocity of the water higher? Is it point A, point B, or if equal, then mark C. So, according to the law of continuity, we know that for a fluid that is steady and incompressible, such as water flowing through the system, the flow rate must be the same. So the flow rate Q, or QA, flow rate of A, is equal to the flow rate of B, QB. And the flow rate depends on the velocity and the cross-sectional area. So for example, starting with A, the flow rate of A, QA, is equal to the velocity of A times the cross-sectional area at point A. Likewise, the flow rate of B, or at point B, is equal to the velocity at point B times the cross-sectional area at point B. Now, this means that A and B, being that they have the same cross-sectional area, and we know that they're going to have the same flow rate, therefore the velocity at both A and B will be the same. And the correct answer is C. Now, you might be wondering, well, what about that middle portion? Doesn't that have some effect on the velocity at point B? And well, no, it actually doesn't, because the only difference that occurs at this point is a smaller cross-sectional area. But the cross-sectional area returns to what it is at A in B. So when the pipe narrows, as in this middle section, the cross-sectional area will decrease, and therefore the velocity will increase. So in order to keep the flow rate the same, if the area goes up, the velocity must go down, and vice versa. So in the middle portion, the cross-sectional area goes down, and therefore the velocity goes up. But once again, after it enters the next portion of the pipe, where we have point B, that cross-sectional area will return to be larger, and therefore the velocity will go back down and be the same as A. So the correct answer is C.